Assalamualaikum and hi doctors. My name is Farha Alina and my final year project title is Experimental Evaluation of 3D Printed Curved Composite Structures for Prosthetic Ankle. For your information, approximately 1/3 of amputees express dissatisfaction regarding the use of their prosthesis. A lot of research have been done to approach this matter. Firstly, one of the studies concluded that one of the reasons for discomfort in wearing lower limb prosthesis is due to the heavy weight of the device. Apart from that, functional and physical properties like its mechanical strength also influence patient satisfaction with transtable prosthesis. Furthermore, fabrication technique is also one of the factors that causes the downhill of the prosthetic field due to labor and time consumption. Hence, this research focuses on additive manufacturing as a fabrication method due to its simplicity and accurate production. A few combination of composite materials is studied and compared to make up the prosthetic ankle that are able to satisfy the need of the users. To achieve the purpose of this study, 3 objectives must be accomplished, which include to design a 3D printed curved prosthetic ankle which is the energy storage and return foot using computer-aided design. Second, to fabricate actual prosthetic ankle prototypes using nylon carbon, PLA carbon and PETG carbon. Note that the carbon fiber act as reinforcement material and will be constant for all prototypes produced. Lastly, all of the prototypes will be evaluated in terms of its mechanical performance, which follow the ISO 10328 standard. Structural testing of lower limb prosthesis. Moving on is the literature review, which is the previous studies that is closely related to my research. There are quite a number actually, but this 3 has become the source of motivation of my project. The first one is where the researchers intended to design low-cost prosthetic foot with pure PLA using additive manufacturing. They managed to gain a good result using a technique called topomization, but its strength still inadequate for amputees with high activity level. The next study is an investigation into prosthetic feet made up of only carbon fiber, and turns out that it is able to provide bending and compression properties to aid amputees in moving forward. This proves the eligibility to use carbon fiber as the reinforcement material in the prosthetic. However, the idea of reinforcement comes from the last study, which succeed in proving that carbon fiber reinforced 3D printed prosthetic able to reach dynamic classification similar to industry standard. As mentioned earlier, the polymer or thermoplastic chosen that will be reinforced by the carbon fiber is nylon, PLA and PETG. The reason why these materials are chosen is due to its mechanically strong properties. Nylon is a semi-crystalline polymer with strong combination of thermomechanical characteristics, chemical resistance, which makes it good for outdoor activities, and processability. Polylactic acid is incredibly famous in the world of 3D printing due to its simplicity, low cost and sturdy characteristics. Lastly, polyethylene terephthalic glycol or PETG has low weight, impact resistance, tough and flexible properties.